Hello students, in today's class, we are going to discuss the perfectly inelastic collision. We have already seen in the previous classes what is elastic collision and what is inelastic collision. Now in today's class, we are going to discuss perfectly inelastic collision. So if you see this perfectly inelastic collision, in this collision also, what we have seen already for inelastic collision, that is the momentum is conserved and kinetic energy is not conserved. So that conditions only are applicable in this situation also. So here we apply the first one, momentum is conserved and kinetic energy is not conserved. Then what is the difference between the inelastic collision and perfectly inelastic collision? I repeat, there also we have seen in an inelastic collision, we have seen the momentum is conserved and kinetic energy is not conserved. And here also we are seeing both the situations, both the conditions, same as the previous one. Then what is the difference between the two? The difference between inelastic collision and perfectly inelastic collision here is when the two bodies collide, they get separated and they move with individual velocities. And that the condition what we observe in elastic collision, that we observe in an inelastic collision. But in a perfectly inelastic collision, what happens? The two bodies collide, and after collision, they will stick to each other and they are going to move with the common velocity. So here also, what we observe here is the loss of kinetic energy will be there, and we can say the maximum loss of kinetic energy we observe in case of perfectly inelastic collision. Now let us see, when two bodies they collide, and the collision we consider it to be like perfectly inelastic collision, then after the collision they are going to move with the common velocity. And what is that common velocity we are going to check now. Now for that, what I do here is, see, suppose a body is there, a sphere of mass m1, and this is moving with velocity u1. It is colliding with another sphere of mass m2 moving with the velocity u2. Both are in the same direction. Okay, that is the condition. Next, after collision, this m1 is moving with the velocity v, and m2, now pay attention, this is m2, they will get stick to each other, right? So yes, stick together. This is m2, and this m2 is also moving with the same velocity what we have seen here. So both will get stick to each other and both together they are going to move. So the common velocity I am considering it as v. Now students, if I apply the law of conservation of momentum, that is the linear momentum, the what is the momentum here? This is m1 u1 plus the momentum over here m2 u2, that is equal to the momentum here, it is m1 v plus the momentum for this, it is m2 v. I am not writing here, you can observe I am not writing here v1 and v2. Why? Because the two bodies, they are moving with the common velocity. That common velocity, we are calling it as v. Now, students, if I take this v common, that is m1 u1 plus m2 u2 is equals to m1 plus m2 into, this is the common velocity v. Now, what is this v? V is equals to, I take this term in the denominator, so this is m1 u1 plus m2 u2 by m1 plus m2. So this is the common velocity with which they are going to move. Now, I said the kinetic energy is not conserved. That means there is a loss of kinetic energy. So how much is the loss of kinetic energy? That we calculate. But before calculation of kinetic loss in the kinetic energy, let us see what is the value for coefficient of restitution under this situation. So we go for the next, coefficient of restitution. Coefficient of restitution. that we denote it by E. And already I have given you the value for coefficient of restitution for this situation perfectly inelastic collision. It is 0. How it is 0? Let us see this. E value we define as relative velocity of separation, ratio of relative velocity of separation to the relative velocity of approach, v2 minus v1 by u1 minus u2. Now clearly you can see u1 is u1, u2 is u2 only. But what is v1 after collision? Final velocity of the first body, it is v. Final velocity of the second body, that is also v. That means v1 and v2 both are v only. So therefore what I do here is, this is v and this is also v. This is u1 minus u2, that is equal to 0. That is v minus v, that will become 0. So coefficient of restitution under this situation, that is under the situation where we observe the perfectly inelastic collision, the value is for the value for E, it is 0. Now the third one, that is the very important thing, that is the loss in the kinetic energy. As I said you, there is a maximum loss in the kinetic energy during the collision. So how much is the loss? Let us see. Loss in kinetic energy. So this loss in the kinetic energy, this also we have discussed, that is 1 by 2 m1 m2 by m1 plus m2 into u1 minus u2 whole square into 1 minus e square. This already we have discussed this. So loss in the kinetic energy, whether it is inelastic collision, elastic collision, or perfectly inelastic collision, this is the situation. But here, because we are having different types of collisions, the values for E will be different. Now under this situation, what we are discussing, the value for E, it is 0. So let us calculate what is the loss in kinetic energy in this situation. So here, this is 1 by 2 m1 m2 by m1 plus m2 into u1 minus u2 whole square 1 minus this is 0 square. So what is this 0 square? 0 square is 0. So 1 minus 0 is 1. 1 into something is the same thing. So I write this as 1 by 2 m1 m2 by m1 plus m2 into u1 minus u2 whole square. The very important thing what you have to take care under the situations for using the different formulae. Here I have assumed the two bodies, they are moving in the same direction. If that is why we am taking here plus, you can see m1 u1 plus m2 u2. If suppose both are moving in the opposite direction, then I would have taken m1 u1 minus m2 u2. That's the thing what you have to take care. Next, here also when you consider the loss of kinetic energy, so here we have considered the situation what I have drawn on the board. The two bodies, they are moving in the same direction. So here we are getting u1 minus u2 whole square. If suppose they are moving in the opposite direction, then we would have taken, that is the same formula, but instead of writing u1 minus u2 whole square, we would have taken u1 plus u2 whole square. That's the only difference. I hope you have understood what is perfectly inelastic collision. Here you have to remember only one thing. This is also a type of inelastic collision only, but after the collision, the two bodies move together with a common velocity. I hope you have understood the concept. Students, we have seen the concept of inelastic collision, and we have seen that the momentum is conserved, kinetic energy is not conserved. What is the common velocity which both the objects, both the spheres, they are going to move after collision. And we have seen the loss in kinetic energy also. Let us see the problems on the same concept. The first problem on the board here is an object of mass 80 kg moving with the velocity 2 meters per second. So the first object is there. You can see I'm writing the given data. M1, an object of mass 80 kg. And this is moving with the velocity, initial velocity, how much it is? 2 meters per second. Hit by collides with another object of mass 20 kg. Here, the second one, M2. M2 is 20 kg. And this is moving with U2, that is 4 meters per second. Find the loss of energy assuming a perfectly inelastic collision. So here we need to calculate the loss of energy. One thing to be careful here, they have not mentioned in what direction they are moving, whether they are moving in the same direction or they are moving in the opposite direction. You can see it clearly, an object of mass 80 kg moving with velocity 2 meters per second collides with another object of mass 20 kg moving with the velocity. It's nothing is mentioned. So we have to consider both are moving in the same direction. So if suppose the objects or the spheres, they move in the opposite direction, 100% they are going to mention that. So here, what I do, the loss in kinetic energy is equals to 1 by 2 m1 m2 by m1 plus m2 into u1 minus u2 whole square. Now students, this is 1 by 2. What is m1? M1 is 80 into 20 by 80 plus 20, and this is what u1 minus u2. u1 is 2, u2 is 4. So what I do, 2 minus 4, it's a square. So it is 1 by 2. You can see it is 8 into 80 into 20, that is 1600 divided by, you can see this is clearly, it is 100. And this you can see here, 2 minus 4, it is minus 2, and minus 2 का स्क्वायर अगर आप करते हैं, minus 2 का स्क्वायर करेंगे तो बेटा प्लस 4 आएगा भाई, बिकॉज माइनस इंटू माइनस इट बिकम्स प्लस. सो यहाँ पे मैं लिखता हूं minus 2 square. Now this get cancelled, and this is 1 times, and you can see this is what, 8 times. So this is 8 into, this will become 4, and 8 into 4, that is 32 joule. Let us move to the next problem. The next problem on the board here, we can see a bullet of mass m moving with the velocity v strikes a suspended wooden block of mass capital M. If the block rises to the height h, then the initial velocity u of the bullet must have been. That's a very good question. Now here what we have, one block is there, and this block is suspended. You can see this is the block here, this is the block, and this block is of mass capital M. One bullet is there, this bullet of mass small m, and it is moving with velocity u as per the question, initial velocity u. It's going and hitting this block. And what happens, you know, it's a block means it is a wooden block. Once the wooden, with this bullet hits the wooden block, that will get embedded into it. उसी के अंदर हो जाती है बेटा बुलेट. एंड व्हेन दिस स्ट्राइक्स दिस, यू नो, ये स्ट्राइक करने के बाद द होल सिस्टम जो है ना, इट इज राइजिंग अप. इतना राइज हो गया, कितना राइज हुआ, लेट अस सी. इफ द ब्लॉक राइजेस टू द हाइट h, कितनी हाइट, यहां से लेकर यहां तक, यू कैन सी दिस हाइट, हाउ मच इट इज राइजिंग, h. So we have to calculate what is the velocity u if the block along with the bullet is rising to the height h. I hope it is clear. Once again, this bullet is of mass m and moving with the velocity u, is hitting a block of mass capital M. It's just hanging. So when it hits this, so after collision what happens, this bullet will get embedded into it. यहाँ पर embedded हो जाएगा बेटा, इसके अंदर आ जाएगा, और this bullet along with the block is rising to the height h. तो height h जाने के लिए what is the initial velocity? That is the question here. Remember, whenever this is the concept what we have already studied in motion in a straight line. Whenever you want to rise any object by giving certain velocity to a height h, एक ऑब्जेक्ट को अगर आप हाइट h तक पहुंचाना है तो आप कितनी वेलोसिटी देंगे, that is under root of 2gh. For this I am explaining, let us see. This is the basic concept what I am explaining here. See students, this is one body is there, and this body I am giving some velocity u, and I want this to move up to the height h, and you know, here the velocity, that is the final velocity, will become 0. So with how much velocity I have to project this object so that this object is going to rise to a height h. So for that, you know the condition, v square minus u square is equals to 2as. Motion in a straight line, you know this concept, v square minus u square is equals to 2as. What is v? V is 0, so I take 0 square, minus u square is equals to, this is 2, but a is minus g, the body is moving away from the earth. So therefore what I do here, it is minus g. And what is s? S is the vertical displacement, therefore I take it as h. So you can see clearly minus u square is equals to minus 2gh, minus minus get cancelled, u square is equals to 2gh, and we are getting u is equals to under root of 2gh. So I repeat once again, whenever you want any object to move to a height h, so with how much velocity we have to project? We have to project that with a velocity under root of 2gh. This you have to remember, the concept what we are using here. Now come to the actual problem. This is the, what I can say, the concept we are using here. Okay, now actual problem, before collision, that is, it's a collision, whether it is elastic collision, inelastic collision, irrespective of that, the momentum is conserved. Momentum is conserved means the momentum before collision and the momentum after collision must be the same. So I apply, and we know moreover, this is a perfectly inelastic collision. Why it is a perfectly inelastic collision? The reason here is, before the collision, this is having its own velocity u, this is also having its own velocity 0. It is at rest, so that's why I'm saying it is having 0 velocity. But after collision, both are stick together, they are attached together, they are combined, and together they are moving. That means this is a perfectly 100%, it is perfectly inelastic collision. So it is inelastic collision, and that is perfectly inelastic collision, but we say the momentum is conserved. That is, the momentum before collision is equal to the momentum after collision. So momentum before collision, what is the momentum here for this? Momentum for this, it is mu, plus momentum for this, capital M, but it is what I can say 0 because it is at rest. This is the momentum, total momentum before collision. Now let us go for just immediately, जैसा ये hit करेगा बेटा, it is going to move with the velocity v. ये v की velocity से move होगा, and it is moving like this. So this v is the common velocity for both. Do you agree? Common velocity for both. That means bullet के लिए भी v है, mass m block के लिए भी v है. So that what I do, it is m into v plus capital M into v. दोनों के लिए भी v है, because after collision they are moving with the same velocity. Now what I do here is, this is mu is equals to, from this what I can take common? I can take common v. This is v. So it is mu, that is equals to m plus m into, what is this v? V, I want this object together, combined mass, this has to reach to a height h, इतनी हाइट तक ऊपर जाना है, तो ये वेलोसिटी कितनी होगी बेटा? हाउ मच शुड बी दिस वेलोसिटी? दिस वेलोसिटी मस्ट बी इक्वल टू अंडर रूट 2gh, तब जाके ये ब्लॉक और द ऑब्जेक्ट विल राइज टू द हाइट h. अगर इससे थोड़ा भी कम रहेगा, इट इज नॉट गोइंग टू रीच दैट हाइट. ठीक है, तो अगर यहाँ पे कितनी वेलोसिटी होना है, यहाँ पे इतनी वेलोसिटी होना है, अंडर रूट ऑफ 2gh, सो दैट इट इज द ब्लॉक इज गोइंग टू मूव टू द हाइट h. सो दिस v आई एम राइटिंग इट एज अंडर रूट ऑफ 2gh. So this is what we are getting. Pay attention. यहाँ पे हमारे क्या मिल रहा है बेटा? यहाँ पे as per the question we need to calculate u. So this is m plus m into under root of 2gh by this small m. I hope the question along with the solution is clear. My students, let us move to the next problem. The next problem on the board, you can see. The next problem is a particle of mass m moving with a speed v in a positive x direction. So how the particle here it is, you can see clearly, this particle, it is moving in the positive x direction. इस तरह से move हो रहा है बेटा with the speed v, and the particle is having the mass m. So collides perfectly inelastically with another particle moving along the same speed in positive y direction, मतलब y direction की तरफ जा रहा है, और एक particle है यहाँ पे, one particle is there of mass m moving with the speed v only. जब ये दोनों आकर कोलाइड होंगे यहाँ पे, somewhere यहाँ पे कोलाइड होंगे, तो आफ्टर कोलिजन इट इज परफेक्टली इनइलास्टिक कोलिजन. मतलब क्या होगा? ये दोनों स्टिक हो जाएंगे, they get attached, and after attaching we have to calculate, find the final velocity of the combination. तो दोनों combine होंगे, combine होकर जब move होंगे तो what is the final velocity we need to calculate. Now this question already asked in the competitive exam, so let us go. When the two objects have a perfectly inelastic collision and they move with the common velocity, what is the formula for the common velocity? Just now we have derived the common velocity v is equal to, this is the v common, I can say this is m1 v1 plus m2 v2 by m1 plus m2. But here you can see the directions are not same. They are, one is towards the positive x-axis, this is the positive x-axis, and other is towards the positive y-axis. They are not having the same direction. So instead of representing the common velocity in magnitude, what I do, I take a vector form of this. Just I'm taking, because velocities are vector quantities, so therefore I'm taking the vector form. So the complete concept I'm expressing in terms of vectors. What is the reason of expressing this in vectors? Because I don't have the same direction, so that I can use m1 v1 plus m2 v2 by m1 plus m2. Instead we are using m1 v1 bar plus m2 v2 bar by m1 plus m2. The reason here is both are not moving in the same direction. Now what I do, when I represent for this, इस velocity को जब मेरे को represent करना है, तो v1 I can represent, this is v1 toward this side, right? So v1 bar I can represent, this is what v, and this is the positive x-axis. So you know students, we represent x-axis by I, y-axis by j, and z-axis by k. So here the, if I take v2, I want to represent for v2 this object के लिए, अगर मेरे को v2 बनाना है, this v2 I can write, but here the magnitude is v only, and here I have to write it as j. Once again, the velocities I am expressing in vectors form because the directions are not same. Here it's clearly mentioned one particle is moving, this is moving towards the x-axis, positive x-axis, that's why I have taken v, this is v only, and this is I cap indicates the positive x-axis. अगर यही प्रॉब्लम में बेटा पार्टिकल अगर मूव होता है टुवर्ड्स द नेगेटिव, इस तरफ जाता होता ये पार्टिकल टुवर्ड्स द नेगेटिव जाएगा, देन वी वुड हैव टेकन माइनस आई कैप. अब यहाँ पे देखिए, द सेकंड वन इज मूविंग विद द वेलोसिटी v एंड इट इज मूविंग टुवर्ड द पॉजिटिव y एक्सिस, दैट इज व्हाई आई हैव टेकन vj cap, that is v2. Now we got what is v1, what is v2, and of course this v2 means it is v2 bar only because we are expressing in vectors. So just substitute here, m1 is m, what is v1, it is vi cap, plus m2 is m, this is vj cap by m plus m. Now students, you can see clearly I can take mv common, m and v I can take common, this is I plus j by 2m. This m get cancelled, and the final answer is v by 2 into I cap plus j cap. I hope you have understood the vector form of the representation of common velocity.